when you're dealing with vectors and scalars, right, obviously you need to know examples of vectors, examples of scalars. No? So some of examples of vectors that we have, just for the sake of multiple choice, we have displacement, displacement, we have force, force, and then we have velocity as part of the examples. We have velocity, we also have acceleration, and then we also have weight. Remember, weight and mass is not the same thing. And then electric fields, right? Yeah, and the others. So these are examples of vectors. So right now we're gonna zoom in on the forces. So a vector is anything, it's a physical quantity that has magnitude. It's a physical quantity that has magnitude and direction. Okay? So when we say magnitude, we mean size. For example, Mr. Tabo, right now I can't say to you it's 2 o'clock to the south. You understand? I can't say to you it's 5 a.m. upwards. You understand? So some of these things, they don't need you to add direction on them. So those things that you don't need to add direction, we call them scalars. So examples could be time, examples could be mass, it could be speed, it could be distance. All of those, they don't need direction. I mean, for example, let's say you're moving like this on a road that is like this. Ne? You're moving on a road that is like this. Apparently, this is Mrs. Sivan's home, and then that is her before she go to school. She goes somewhere first, you understand, before she reach school. But if I ask Miss Sivan, like now, let's say she came to school, I ask her, uh, how like what was the total distance, what was the distance that you traveled, right? Miss Even can say mamela, she can't say I traveled 1 meter. You can't see. Oh, okay, don't worry, you work with the voice. Yeah, so mama, she can't tell me that I went 1 meter up, 1 meter down. Remember, when you're walking in terms of distance, you are doing a lot of turns. So there is a lot of direction that is going to be involved. So, but then distance includes all those directions. But with displacement, we just look at from where you started to where you ended. That would be displacement. It's not distance, but it's displacement. It looks at your final position and your initial position. Whereas distance is the total path length, and then distance is scalar, while displacement is vector. So things like moving at 60 kilometers per hour, southwards, that is a vector there. So that is velocity. It has size and direction. Okay, so but then when we zoom into force, we need to do calculations, especially in a Cartesian plane. But to start with what we are doing there, let's understand the following. F net, which is the resultant force, is a combination of two or more, is a single force that has the same effect as all other forces combined, which means you are adding F1, you are adding F2, you are adding F3, etc., depending on the amount of forces that you have. But I think what is not really emphasized at school, which I think is crucial, is that you are not just adding forces here. You understand? You are not just adding forces. These forces, right? These forces that you will be adding, all of them must be in the same direction. Okay? So we are not just adding forces here. They must be going in the not same direction. They must be in the same plane. Um, yeah, let's call it same plane. Now, what do we mean by plane? There is a vertical plane and then there's a horizontal plane. So when you are adding the net force, you must be adding forces that are in the same plane. Either all of these forces, they're acting vertically, or all of those forces are acting horizontally. You understand? You are not just aiding them, they're acting horizontally. An example could be you. Think of you when you are standing on the ground. So when you're standing on the ground there, and then this is you, if you are walking, you'll be walking to the right, ne? You'll be walking to the right. Then you have to understand that some people can be walking to the left. You understand? So the fact that there is two possibilities, there is a right and left, these are two different directions. But the fact is that those different directions are in the same plane. They're in the same what? Plane, which means, and what plane is that? The plane is horizontal. You understand? That is a horizontal plane, left and right. So there is another plane. Which plane is that? There is a vertical plane, which means the y direction, the vertical direction. And that direction is if you were to start jumping. If you were to start jumping, now you are moving, there is now either up or down. You have unlocked other possibilities. You're talking about up or down. So that one is called a vertical plane. You understand? So if you are moving up and down, that is a vertical plane. So understand the following: there are forces that act in the horizontal plane, and then there are forces that act in the vertical plane. Never should we ever add the forces that are acting in different planes on one equation. For example, let me give you a practical example. Let's say this is simply a block here, right? This is simply a maybe 2 kg block, right? A 2 kg block. As it is resting on that surface, right? Someone can even come and maybe try to push it there. So here's someone pushing it. If I were to draw the free body diagram for this block, the first thing is that there is someone who's pushing it. So I must show that there is a force applied, and then because it's resting on a surface, there will be normal force acting perpendicular. So Mr. Kevin, I'm not only saying that there is normal force just because there is a block, but I'm saying there is normal force because the block is resting on a surface. That means if it was hanging in the air, there won't be normal force. Now, another thing is that the block is going to have force of gravity. The reason why I'm saying it has force of gravity is because it has mass. Understand that anything that has mass is going to be pulled down by the force of gravity, by the Earth's attraction force on it. You understand? So that is why Fg is always down, because the Earth pulls everything that has mass down. And then it could be that it's a rough surface. So because it's a rough surface, I'm going to have frictional force acting in the opposite direction. So tell me something. Which forces are acting in the vertical plane, and then which forces are acting in the horizontal plane? Can you be able to identify them here? Say, if you are able to identify this, you are done with physics. We can close the session right now. Because, why am I saying that? This is because whenever they're asking you to say calculate Newton's laws, what, when you write F net, you are either, mamela carefully, like when I say F net, you are either adding Fk plus Fa, or you are adding normal force plus Fg. So it's just that according to Newton's laws, you then say your F net is equal to ma first. You understand? Your F net is equals to MA, right? Let me start it here. I'm sorry for combining this with Newton's laws, but I need you to understand the following. Whenever you're writing F net is equals to MA, and the next thing is to add forces. Which forces are you adding? You must be either adding the forces that are acting horizontally, you understand, or you must be adding forces that are acting vertically, which means normal force plus Fg. You understand? So that means never is there an instance when Mr. Tabo, never is there an instance you're gonna say normal force plus Fa if these two are not acting in the same plane. Are they acting in the same plane? No. The other one is acting in the vertical plane, the other on the horizontal plane. We cannot do that. We are not allowed to do that. Yes, you can ask, eh? Mm-hmm. Mm. 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 Thank you so much for that question, sir. That's a beautiful question. So, Mr. Kevin is asking to say, hey, say, if I see a force here, like this, usually the force there will be, let's just say it's tension this time. I want to just call it tension, right? Or let's just call it force 2, force number 2. Since already there's force number 1, so that means I can just write that this is applied force number 2. So that force number 2, it would be here. Do you all agree with me that it is there? Are we all together? Right. So since that force is there, can you tell me something? Is F2 acting up, down, left or right? Sorry. Mm. Mm-hmm. Right. So some of you are saying, uh-huh. Okay. So some of you are saying it's F2. They're saying it's between diagonally. That means F2 you can't describe it as either up, down, left or right. You have to do a combination. So the question would be, my question would be now, since F2 is acting diagonally, do we say it's part of vertical or do we say it's part of horizontal? Actually, I think that is what Mr. Kevin is asking. Do we say F2 is part of horizontal or part of vertical? So I'd like to hear from you guys. Anyone, do you think F2 forms part of vertical or part of horizontal plane? Yes, ma'am. Mm-hmm. Or it's acting what? Okay. Eish. All right, all right, all right. And then anyone else? It's acting both horizontally and vertically. Okay. No, very good responses. And yeah, I hope, ma'am, your screen problem there. And now I'm realizing it's you, not me. Eh? It's you, ma'am. Mm-mm. Yeah, the question is F2 is acting vertically or horizontally. When you check F2 there, you can't really classify it as horizontally or vertically. But the thing is that it's important for you to classify it, because you need to tell us whether you're going to add it as part of this equation here, or you're going to add it as part of this equation with those that are acting vertical. So here's the thing, Mr. Kevin. When it's like that, it's acting in both directions. You must understand that it's acting in both directions, which means there is a part of it. Listen, there is a part of it that is acting to the right, and then there is a part of it that is acting upwards, and itself it's in the middle. Are you able to see this? There is a part of it that is acting to the right, and and there is a part of it that is acting upwards. Itself, F2, we're not going to include it in the calculations, but we're going to include its parts. So when we say a part of it, that part is called a component. A part of it is called a component. That is a part of F2. So these components, there are two. There is a part of F2 that is acting vertically. We call it a vertical component. And then there is a part of F2 that is acting horizontally. We call it a horizontal component. Understand? So the vertical component, we still call it F2, but we add a subscript Y to indicate that it's still F2, but F2 which is acting in the vertical direction. Whereas here, we still write that it's F2. However, we put a subscript X to indicate that it's still F2, but which is acting horizontally. So the X is to indicate that it's acting horizontally. The Y is to indicate that it's acting vertically. So the next question would be, how do I find the size of the one that is acting vertically, and then how do I find the size of the one that is acting horizontally? That is why we have formulas for them. For the one that is acting vertically, you can say F2y is equal to the magnitude of F2 itself. The magnitude of F2 itself, meaning the size of F2 multiplied by the sine of the theta, which is the angle between F2 and the horizontal direction. So the angle here is the one that we use now to get the size of F2. F2y. And then the one that is acting horizontally, if I want its magnitude, I will say F2x, then I say F2 multiplied by cos of the same angle that we're talking about. In that way, once we are done calculating F2 and Fy, that's when we can come here and say we must also add F2x. And then that's when we come here and then we say we must also add F2y. In that way, you have successfully placed F2 in the horizontal and in the vertical. Is there any question? Do we understand? In layman's terms, in simple words, we are saying that any force that is acting diagonally has a part of it which is acting vertically and a part of it which is acting horizontally. In any force that is acting diagonally. If you can just remember that, you will be fine. So, back to the question itself. Now, so how do we deal with that? So let's understand the following. If I have let's just say I have F2 here, and then I have F1 here, and then F1 is 10 newtons, whereas F2 is 15 newtons. These are acting in the same plane. They're acting horizontally. So I can simply add them. I can find their resultant by saying F1 plus F2. That will be their resultant, the F net. Do you understand? Because F net means you are adding them. But Remember, the reason why I'm adding them is because they're acting in the same plane. So I must then choose direction in that same plane. If you're talking about the horizontal plane, if you're talking about the horizontal plane, there will be those that are acting to the left or those that are acting to the right. For me, I need you to remember this structure. This one. This structure means horizontal plane, and then this one is vertical plane. In your vertical plane, there will be forces acting up, there will be forces acting down. Whereas in the horizontal, there will be forces acting to the right, and then there will be forces acting to the left. You are able to add these by saying F net, and then you are able to add these by saying F net, but you can't add this one and that one. No, it doesn't work like that. So similarly here, they're in the same plane. The other ones are going to the left, the other ones are going to the right, so you can simply add them. That is why now it's important to indicate the direction. To indicate the sign of the direction, to say that those that are acting to the right, we shall make them positive. You are the one who decides that. You understand? To say, I want those that are acting to the right to be positive, or I want those that are acting to the left to be positive. No one will penalize you even if you choose those to the right to be to the left to be positive. No one will penalize you because you are the one who's allowed to choose the direction. So that means since F1 is acting to the left, and I've already said those that are acting to the right are positive, that means F1 must be negative, and then F2 must be positive. In that way, my answer is gonna be 5 newtons. However, the answer that I got is positive, which means that the F net is to the right. Right? Is that okay? Okay, perfect. Now let's talk about force vertically. Let's just say this is F1, which is 10 newtons, and then let's just say here we have another force acting upwards, F2, which is 5 newtons, and then we have another force that is acting down, which is F3, which is 6 newtons. Let's just say actually 12 newtons. Tell me something, or let's say, sorry, 16 newtons. Tell me something. Where do you think F net will be? Do you think F net will be up, or do you think F net will be down? So what you can do for me, you are able to type here on the chat box. Just write up or just write down so that I can see your answers there. You see, I already started. I said up. Don't. If you also think it's gonna be up, write it there. Where do you think F net is going to be? Is it going to be up or is it going to be down? Good people, I'm still waiting for those. Okay. Are you guys able to hear me? Okay. Okay, perfect. If Yeah, so I see some of you say up, some of you say down. Okay, that's good. Let's actually calculate to find out. So our F net is going to be F1 plus F2 plus F3. However, we must choose direction. So we're going to choose those that are going up to be positive. But remember, the reason why we're adding them is because they're acting in the same plane. All of them are acting vertically. So we shall say our F net is equals to, remember F1 is going up, so it's going to be positive. F2 is going to be positive. And then F3 we have to put negative because it's actually acting down. So therefore we shall have 15 minus 16, and therefore that gives us minus 1 newton. So which means that it's 1 newton. So F net is equal to 1 newton where downwards. You understand? So that means it's 1 newton downwards. That's where your F net is going to be. So which means your F net is gonna go like that. Now, to clearly see the direction of F net, that is why at school you are taught about the head to tail method, so that you are able to visualize that. But unfortunately, we won't be able to have time for that. So now I'm just gonna quickly run to those that are not to a combination. Let's say that I have a Cartesian plane, right? Let's say this is my Cartesian plane, and then let's say I got a force here. Here's a force here. Yeah, here's a force here, and then here's a force here, right? So I'll call this F1, and then it's 50 newtons, and then I'll call this F2, and then it's equals to, then there is a 30 degrees there. So how do I calculate the F net? Right, is it allowed for me to say F net is equals to F1 plus F2? Is that allowed? Can someone answer me there? Is it allowed? No, because they're not acting in the same plane, right? So what do we do? Guys, it's quite simple. What you do there is is that you split F1 into 2. So you're gonna split it into the one that is acting horizontally, and then you're gonna split it to the one that is acting vertically. So for the one that is acting horizontally there, you still say it's F1 but you put X. This one you still say it's F1 but you simply put Y to indicate that it's acting vertically. So after you are done doing that, what do you do? Are you done? No, you're not done. You still need to add here. So for me, this is how I make it so easy. You just have to draw a T table. You draw a table like this, ne? Then after you draw that table, I want you to do this. I want you to write vertical, and then I want you to write horizontal. All my students who have used this, they find this quite easy. You say vertical and you say horizontal. Do you know what you do next? Simply, ne, I need you to list all of those that are acting vertically. It's F1Y. Do you agree that is the only one that is acting vertical? Is there any other? No, it's only F1. Remember, remember F1, we don't count it. We don't count it. We count its components. We count its horizontal and vertical components only. Itself, we don't really count it as part of this. So then, because remember, Kiri, you said you can't place it here or there. So why would you want to add it now? Okay, so those that are acting horizontally, it's going to be F2, and then it's going to be what? It's going to be F1X. Do we agree with that? Perfect. Once you have this now, do you know what you do next? You write, since you do not know F1 for now, you write its formula. Remember, it's F1 multiplied by sine theta. So you say, how much is F1? It's 50. You multiply by sine of the angle, which is 30 degrees. Then as someone, please do, I think I have a calculator here. 50 times sine 30, we get 25 newtons. So that is 25 newtons for F1Y. Then let's get F2. How much is F2? Oh, sorry, I have to give you F2, guys. So this is 40 newtons for F2. So it's given to be 40 newtons. And then what is F1X? This will be F1 cos theta. So that means you're going to say 50 multiplied by cos of 30 degrees. So if you do that, you say 50 multiplied by cos of 30. You get, let's round it off, ne? 43 0.30 newtons. So that is F1x. Guys, immediately you are done doing that, ne? You then are going to write for me Ry. Here you're gonna write Ry here. And then here you're gonna write for me Rx. What is Ry? What is Rx? Ry is the F net for the vertical. Remember, Kiri, when I have to it's all forces acting vertically. I'm adding them. So in this case, I simply have F1y. There is no other one. Open. So I'll just choose up to be, but make sure you choose that. So I'll choose up to be positive. So apparently it's only gonna be F1y here. But then here I'm going to choose the right as positive. Okay, I'm gonna choose to the right as positive, because remember, horizontally it's either left or right. So Rx is going to be F2 plus F1x. You understand? Is the addition of those that are acting horizontally. That is x. So therefore, your F2 is how much? Your F2, remember, it's going to the left, right? Remember, this is F2 here. Remember, it's going to the left. So we have to give it a negative there. So we would say negative 40 plus, this one is going to the right, F1x is going to the right, so we say it's 43,3. So if we add there, we get that is 3,3 newtons, and it is where? To the right, because the answer is positive. Whereas here we're gonna have 25 newtons up. That is your Rx and that is your Ry. Now to get F net, you are simply gonna say is the square root of Rx squared plus Ry squared, more like Pythagoras theorem, you see. Therefore you would say your F net is, for Rx is gonna be 3,3 squared, and then for Ry is gonna be 25 squared. Therefore what will be your F net? Sorry, so square root of 3,3 squared plus 25 squared. So your answer is 25,21 newtons. That is your F net there. That is your F net. And that's how you get it. Huh? Oh, 2,2. Yes, thanks. Man, so it's 2,2. Guys, what I did there is how you find F net of any amount of forces. You simply have to resolve each force to its components, meaning that each force you must do F1 Fx if it's acting diagonally. For example, for the one that I give you, please do write it, guys, and send to me to check whether you understood this, and I'm gonna send you the recording. But send to me, right, how you think we can do this one. So remember, all those that you see diagonally there, you must resolve them and then put them under vertical and horizontal. Then after that, you send me your answer for for F net. So please do it, guys, né? And once you are done, you can send me send the pictures of what you are doing there. All right.